The bunny, ooh, I love the bunny. I don't want to play on a day that is sunny. Because if you get too much sun, then you get cancer, and that's bad. Unless you get like a way obscene amount of sun, in which case you get superpowers, like I have the superpower to clone myself. So, ooh, I like that. My clone has a great looking nose. We are going to test whether Laramie is safe by testing whether, on average, on a random sunny day, you're in the way, you can't read. Average sunny day in Laramie is less than 100. And we're going to assume that the sigma is 10, and this is the correct units for radiation. I looked it up online. So we are going to sample 40 days and see whether the average is, you're purposely. Now, we did get an X bar that was less than 100, but is that enough to prove it? Well, we want to do two things. That's draw the picture and do the hypothesis test. And fortunately, there's two of me to do it. So you draw a normal bell curve, and I'm going to see if I can do the hypothesis test. You need a marker. So here we had the average, and it says less than 100. Get a marker, draw a bell curve. So somewhere on my hypothesis test, I want to have average less than 100 because that's what the question asked for. Is this the null or the alternative? Well, I don't know yet, so let me think about it. Here there's no equal sign. That tells me this must be the alternative. Now that I know what the alternative is, it's easy to go back and fill in what the null is. If this is less than, the null must be greater than or equal to. A very common problem students struggle with is they think whatever it says in the question must be the null or must be the alternative. The answer is you have to look at what it's asking for and decide whether it has the equals or not. Now I need my alpha, and I really want to know that it's safe. Why? Because I have kids in Laramie and I want them to be safe. So on my picture, you're purposely standing in front of the picture. So on my picture, I'm going to push my alpha over here less than 0.05. So I'm going to use an alpha of 0.02. Go ahead and add that to our picture. And now I'm going to try to make a z-score, which, let me just real quick calculate that, do that in my head. I think that comes out to a negative 2.15. Okay, so now I'm ready to go to the applet and see what my p-value would be. I need a z-score of negative 2.15. And do I want this to the left or to the right? Well, my alternative said less than. So I want the area less than, which is to the left. So there we go. There is my p-value. So let's add that to our picture. Would you put 100 in the middle? Big 100. And they can't see. You got to scoot. There you go. Okay, now we're going to put our standard error, which is this guy, the 10 over square root of 40. So add that to your picture. Right there. And then put 10 over the square root. Okay, so now we're going to put the negative 2.15 on there. So measure how far that is with your hand. You don't lean back so they can see. There. And then you'll do 1, 2, and a little bit more. But it needs to land on this side of the red line. Okay, so now make a mark there. Reach. Here is our picture. Reach. There. Don't fall. So here's our picture. Here's our alpha, and there's where the 96.6 landed. This alpha cut off 0.02 in area, and our p-value is less than that. That's how I knew that we were supposed to land on this side of the line. So now this area here, shade from there over, even though there's like, and then shade in this little triangle. So this little tiny area right here is 0.01578. So lean back, so you're out of the way. Okay, now this should look like this should look like what we had on the picture on the applet. This guy, does this look like the picture we had on the board? I gotta get back to position. And so what you see here is our p-value is less than alpha. That's why we reject the null. In other words, we were outside this range where our p-value is less than the line that we needed, so that we are rejecting the null. What does that lead us to conclude? That leads us to conclude here the alternative, which said mu is less than 100. We know because mu is less than 100, what can we say? Laramie is safe. Of course it is. It's Laramie after all. And what in the world could possibly be dangerous?